Hello. So today we're going to be taking a look at how to solve multi-object force problems using systems of equations. We're going to start off with a problem from page 164 of your packet. It's number 13. A block of mass M2 slides on a frictionless tabletop. It's connected to a string that passes over a frictionless pulley and suspends a mass M1. Find the acceleration of the masses and the tension in the string. Now, you'll see here this problem doesn't have any numbers. We're just going to solve this with symbols. We'll start off by drawing our force diagrams like we've done before. For M1, there's only two forces. There's gravity pointing down, there's a tension force pointing up. These are not going to be equal because block M1 is going to be accelerating downwards. So that means that the gravitational force is going to be bigger than the tension force. And then for M2, there's going to be three forces. We've got gravity pointing down, there's a normal force or a force of support pointing up, and we're going to have, those are going to be equal, and then we're also going to have a tension force that's to the right. And this tension force is going to be equal to the tension force from M1. Those two tension forces are equal. Now, what we're going to do here is draw in the axes, and there's something that's a little unconventional that we'll do here. So we'll draw those in, and for M2, I'm going to say that to the right is my positive x, and up is my positive y. However, for M1, I'm not going to do the same thing. I'm not going to say that to the right is positive x because these two objects are both moving. M2 is moving to the right, and M1 is moving down. So I want the direction that these are moving to match one another. So since M2, I've done positive x to the right, for M1, I'm actually going to say positive x is downwards, even though it's a little unconventional. And we'll see why that is a little bit later. The main reason is because this object, as M2 is accelerating to the right, well, M1 is accelerating down at the exact same rate. And so when I go in, if I had this being like my downwards was negative and upwards was positive, I'd have to make sure that I paid attention to that as I was setting up my equations. Doing it this way makes setting up the equations a little bit easier. So what I'm going to do is I'm going to set up my net force equation in the x direction for M1. And so for M1, and that's, remember, my up and down direction, the net force is going to be M1 times A in the x direction, just like always. And then I'm going to replace the net force with the actual forces. So Fg1 is down, that's the positive x direction, and T is up in the negative x direction. And then I'm just going to replace Fg1 with M1g, and that's my net force equation for M1. All done. Now we have two unknowns in here. We've got T and Ax. So we need a second equation. That's what our other force diagram is for. So what we'll do for this one, M2, is we can say that the net force is equal to Ma in the x direction, and the only net force in the x direction is the tension force. And so it's just T equals M2Ax. Now, what we can actually wind up doing is we've got two equations and two unknowns. So we can take this value, which is what T is equal to, and plug it in for T in the other equation. Let's go ahead and do that. So if I plug in for T, M2Ax, we get that. Now we have an equation with only one unknown, the acceleration. So what we want to do is bring things, so we'll move this over to the other side so that we gather all of our like terms. So I'm going to move the M2Ax over to the other side, just kind of like this, a little bit of algebra. And then we can solve for Ax. So I'm going to factor out M1 and M2, M1 plus M2, and then divide both sides by that. And I get that Ax is given by this formula here, M1g over M2 plus M1. So it's the mass, it's the weight of one object divided by the total mass of the entire system. If we allow this, here, we'll move this out of the way so we can do a little bit more. And so now what I'm going to do is I'm just going to take that value that we just got and plug it in for Ax into this equation there. So you can see this equation T, it already solved for tension. If we just plug in the value for Ax, that should give us what our tension force is. And then if we rearrange this, I get M1, M2g over M1 plus M2 as the tension force. And so that's basically the way that we do these kinds of problems. Now, if you had numbers, you'd be able to plug numbers into the equations ahead of time, and you could actually do it that way instead. But for this problem, I'm going through and doing it with just the symbols, with the letters. And so at the end, if you had values, you could plug them into this, and this would work for any similar kind of question. But remember, we're not trying to memorize these equations. We're trying to make sure we know how to get to these sorts of things based on the force diagrams. That's the big skill here. So I'm going to give you a few more problems for you to practice yourself. Good luck with those. And then next time we're going to see if you have any questions. All right.